When you start doing equation solving in physics, you're going to find your students need quite a bit of refresher. A lot of times science teachers use a different vocabulary than the math teachers, and the students will have problems applying what they learned in their math class to your science class. So I strongly recommend you teach equation solving to start with, just at the very, very beginning of the year, and then use it throughout the entire year. Vocabulary is essential, and we may be teaching them things they haven't quite learned in math yet. For example, subscripts. A subscript, I tell my students, simply tells you which one. Sometimes I use numbers for subscripts. For example, if I use T for time, then T1 and T2 are different times. I like using numbers for subscripts for time because it's very clear to determine which one comes first. Clearly T1 occurs before T2. Now sometimes we use letters, particularly when we do energy. Let E stand for our total energy, then EA and EB are the energy at different places. I like to use this on roller coaster problems. There are special subscripts. For example, T0 is literally the time at t equals 0, or the initial time. One thing we did when teaching equation solving was we gave a pretest. For the pretest, it was simply these 6 equations. Handed them to the students, did not work them, did not give them any hints, did not show them any steps. Simply ask them, solve these for the different variables to the best of your ability. And that was all that we did on day 1. On day 2, we began showing them how to solve equations. And again, we made sure we understood the same vocabulary they had been using in their math classes. Inverse operations undo each other. Addition and subtraction are inverses, and multiplication and division are also inverses. So if you're adding something and you want to get rid of it, you subtract. If you're dividing something and you want to get rid of it, you multiply. You'll also need to cover squares and square roots because we will be using those. Next, we solve equations in very specific ways. I have the students circle the variable they're looking for in the equation. Next, I have them clear fractions. I've found students do not deal well with fractions. And so if we simply get them out of the way to start with, they're able to solve the equations much easier. And lastly, we use reverse order of operations to solve the equation. Let's step through one. S is 1/2 PL plus B. To solve for P, some students will simply try to write the answer down, but we're going to follow all of the steps. Step 1, circle the variable. I don't make the students rewrite it. This is for demonstration purposes alone. Now, step 2, we need to get rid of the fractions. So I tell the students to hug the equation, and I have them multiply by whatever is in the denominator. A lot of times I simply cover up all of the equation except the denominator so they can clearly see that they need to be multiplying through by 2. You're going to need to show the students how to make sure they distribute this 2 to every element in the parentheses. So you wind up with 2s plus PL, because 2 times 1/2 is 1, and we don't show the 1, plus 2b. So we've circled the variable, we've cleared the fractions. We're still looking for P, so now we need to use reverse order of operations. Alright, we've got this unit here, PL, and we're adding 2b. So to get rid of the 2b, we need to subtract 2b from both sides. Now the students really do like crossing things out. So do I. So 2s minus 2b, because you add straight down, is equal to PL, and then this is plus 0. So we leave it. We need to continue solving. We're looking for P, so we need to divide both sides through by L, and you get a solution. 2s minus 2b divided by L is equal to P. But in science, we don't like to write it this way. We prefer writing it P is 2s minus 2b divided by L. And as a matter of fact, it's a very good habit for your students to always write the variable on the left equals, and then the rest of the equation. Now let's practice. It's essential you step through solving these equations with the students while the students work them themselves. For the first one, solve for W. P is 2L plus 2W. Some of them may recognize this as a perimeter formula from their math class. Circle the W. We don't have any fractions, so we don't do that step. 2W is a unit, so we need to subtract 2L from both sides. And you wind up with 2W is equal to P minus 2L. Now I tend to flip very early, getting my variable on the left. If this confuses you, just carry it through on the right and then flip it at the very end. I'm still looking for W, so now I need to divide through by 2 on both sides. Now, at this stage of the game, I cross out the 2's and I get W is P minus 2L divided by 2. A lot of students will try to go on and solve this down and cross out the 2. That's not correct. You can't cross out the 2 unless there's a 2 in everything in the numerator. And in our equations, we don't tend to have to do a lot of factoring. So I have my students leave it in this fractional form. For the second one, we're going to solve for B. So your first step is you circle B, because that's what we're looking for. But you see in this case, we do have a fraction. So I actually cover it up, and in order for my students to see what it is they need to be multiplying through by. The only thing in the denominator is a 3, so they're going to need to multiply everything through by 3. So they hug the whole equation, multiply through by 3, distribute the 3. They won't have too much trouble with this one distributing the 3 correctly because there's only one element on the right side. So 3B is equal to BH. Still looking for B? So I'm multiplying B by H, so I need to divide both sides through by H to get my answer. Next, they had a couple of equations they needed to solve for themselves. Equation of a line and, of course, the kinetic energy formula. They will struggle with this one because they're going to want to square root to start with. We haven't covered square roots yet. We'll do this in the next day or so. So make sure that they're not square rooting everything. The third day, we review, and this is kind of fun. What are the 3 steps? Circling the variable, clearing fractions using reverse order of operations. You have to put them in order up here. If you try to put them in the wrong spot, they don't stick. So the kids actually like coming up and doing this. First circle the variable, next clear your fraction, and then use reverse order of operations to get your solution. This day, we do use subscripts heavily, so make sure you've reviewed it. Solve for A. V is V naught plus AT. You circle A. We have no fractions, so we don't have to do anything for that. We need to get rid of the V naught. It's being added, so we subtract it from both sides. So AT is V minus V naught. I'm still looking for A, so I need to divide both sides through by T. For K, this is the first time you're really going to get to deal with the square. If you didn't cover it thoroughly the day before, go through to start with, circle K, hug the entire equation, and you're going to know you want to multiply through by 2 because if you cover it up, there's 2 in the denominator. So you multiply both sides through by 2, and you get 2us is kx squared. I'm looking for k. I need to get rid of the x squared, so I divide both sides by x squared. And I get k is 2us divided by x squared. They are really going to want to square root it, and what I tell them is if I have not circled that variable that is squared, then there is no need to square root it. I give them 2 more practice problems. And for these, I'm very careful and I make sure that they're getting these right. These are fairly complicated. This is the most complicated equation we'll use all year long, and they don't like it. But all we're doing is solving for VI. Next we do, on the 4th day, we let them break into groups and see if they can figure out which one of these is correct, if either one is correct. If you have active votes, you can use it or break them into teams and sides of the room. We're looking for V naught, and in both of these we've multiplied through by V naught. We have fractions, so we need to get rid of the fractions by multiplying through by 2. And here is when most kids realize they have not distributed this 2 across to everything on this equation. So this one is incorrect. If you step through, you see that they did distribute it correctly on this right-sided equation. We're looking for V naught. The trick here is they're going to have to subtract 2 things, both minus 2x naught and minus at squared. Some students may need to do this in 2 separate steps. That's just fine. Here we're looking for V naught still, and we're multiplying through by 2t, so we need to divide through by 2t. Again, they may need 2 steps to do this. And they solve it and get 2x minus x naught minus at squared over 2t. Watch them because they're going to want to cancel those 2's out. For practice, now this is where the squares and square roots start to get a little confusing. Most of them can do Pythagoras quite fine. They can't do it with our variables though. So, a squared plus b squared equals c squared. Solve it for b squared. We circle b. Now what I tell them at this point in time, since b is squared, we are going to have to square root it, but we only do that at the very end. We don't have any fractions, so we need to get rid of a squared by subtracting a squared from both sides. So I have b squared is c squared minus a squared. I'm looking for b, so I have to get rid of the square. So I square root both sides. Some students will want to distribute the square root across the c squared and the a squared. I can't do that. I always give them the example of a 3, 4, 5 right angle as an example where a is 3, b is 4, and c is 5. Once I show them with numbers, well, sometimes they believe me. This one, we're solving for x squared, so make sure you circle x squared. We do have a fraction for this one, so we're going to need to hug the equation, get rid of the 2, multiply both sides through by 2. So they're pretty good at getting 2us is kx squared. You can identify your weakest students because they will need that one right there and may need an additional step. You're going to want to work with those kids individually if at all possible. We're looking for x squared, so we need to get rid of the k by dividing. And once you get x squared is 2us, you have to square root both sides. So x is the square root of 2us divided by k. You need to watch because they're going to want that square root to stop about right there. It needs to go all the way down and include the denominator. Two more problems they get to practice. The fifth day is a lot of fun. Again, you can use the active votes, and I have the students vote on which one is correct. You'll see the one on the left, we're solving for t, so for both cases we've circled t. T is the only thing in the denominator, so we need to clear fractions. We've gone through, distributed the t, gotten tp is w, divided through by p, so t is w over p. And for this one, we did it a little bit differently. This is what they would have been doing in their math class, which is put the p over 1 and then cross multiply. You will have a lively discussion over which one is correct. And of course the answer is they're both correct. Proportions don't always work in our class because our formulas don't necessarily lend themselves to this format. This is one of the same reasons using the triangle is very detrimental in your physics class. If I have a problem, however, where proportions can work, I have no problem with them cross-multiplying, and I tell them to do whichever they like. So let's practice. AC is VT squared over R, and I'm looking for R. You will have the most problems when they're looking for something in the denominator. They simply will struggle. So, I'm looking for R. It's in the denominator. I still have to clear fractions. R times AC is VT squared over R. So I get R times AC is V squared T. Now you've got a square and you've got a subscript. They're going to struggle with that. I'm still looking for V. Oh, excuse me, I'm still looking for R, so I need to divide both sides through by AC. And I get R is V squared T divided by AC. It's the same skills we've been using, but they will find this one to be more challenging, simply because of the squares and the subscripts. And we're looking for a variable in the denominator. For this one, again, not only are we solving for a variable in the denominator, but it is squared as well. So, you circle R squared, clear fractions. Alright, make sure they write it nice and clearly. R squared FG is GM1 M2. We're looking for R, so we need to divide both sides through by FG, and then square root both sides. By the time you get to this in your physics class, they'll be fairly adept at doing this skill. They practice, and we move on to day 6. Now, for this one, we've got delta D is VI delta T plus 1/2 A delta T squared, and we're solving it for A. Step 1, circle A. And then they have quite a bit of fun. I have them come up and put these in order. We clearly need to clear the fractions first, and then distribute that across. We're still looking for A, so we need to subtract 2 VI delta T from both sides. Divide through by T squared until we get A by itself. And here, I've simply gone through the steps. Let them practice with 2 equations. These are equations we've used before, and we've done this one, and we've come very close to doing this one. The seventh day is a post-test, where we give equations that are very similar to the pre-test. We found the students do remarkably well on the post-test. By repeatedly using the skills every day for the rest of the year, however, by the end of the year, this is second nature to our students.